Hi, it is the second part of section 5.3, the definite integral. In this part, we'll study properties of definite integrals. We assume both f and g are integrable over the interval ab, and c is chosen from the interval, and k is a constant. Then we have these properties. If you try to get integration with opposite order, that means rather than a to b, we try to get integral from b to a, then in Riemann sum, delta x will be negative, so that the integral must be negation of the integral from a to b. If interval width is 0, then the integral must be 0, because every Riemann sum will be 0. Now, constant is inside the integral, then this constant can go out. In Riemann sum, once for this kf of x, and k can be put outside, factored out, so that you can easily figure out this is true. And sum and difference, integral of f and g, sum and difference, can be obtained from the sum and difference of each integral. Now, for any c, here a to c integral and integral from c to b must be same as integral from a to b. This one is the limit of Riemann integral over the interval a to c. That is the limit of the Riemann sums over c to b, so that eventually the summation is the limit of the Riemann sums over a to b. Right? Okay. Now, maximum inequality. Okay. Here, for given fx, and that is always larger than equal to minimum of f, and that is also smaller than or equal to maximum of f, so that the height is larger and larger, so that integration from a to b should satisfy the same inequality. Right? Integral a to b. But this one is now, this is constant, so that constant times b minus a, so that is a mean of f times here b minus a. Of course, that one must be max of f times b minus a. That is exactly this inequality. Now, termination property, when fx is larger than or equal to g of x for every point, then because their Riemann sums should satisfy this inequality, so that eventually in its limit we have that inequality. Right? Okay. Here, let's solve this example. Suppose both f and g are integrable, and we have this data. Okay, let's try to solve this one. And that one is the same as now. Once we are using sum and difference formula, and that is same as from 79 to f and minus integral 79 and 3g. Now, for constant, we can put it outside, so that there's a twice of 79 integral f minus 3 times integral now 79 g. Okay, this is 5, and this is a minus 4, so the 12 and 10, so that is 22. Okay, for this one, okay, we already know that integral from a to c, c to b is same as a to b. But here 1 to 7, we want to get 1 to 7, but we have only 1 to 9, and then here 7 to 9, so that we may try to use the given information. That is same as here from 1 to 7 integration now plus, okay, no, just a moment. The data is given only 1 to 9, so that 1 to 9 here. And then we try to get here 9 to 7. Maybe it's a bit odd, but anyway, I'll try to explain that one. Okay. Here, integral 1 to 9 is same as integral 1 to 7 plus integral 7 to 9. Right? But what we have to get is this one, so that from this one, now here, integral 1 to 7 is same as integral 1 to 9 minus integral here 9 to 7. Right? Okay. Here, that is same as now changing here order. We can say that is 1 to 9 and 9 to 7 addition, right? Okay. So you may think that anyway, it is the integral is that's integral over whole from maximum to minimum to maximum. Then anyway, 1 to 9, that one, the same here, 9, then eventually it's same as integral from 1 to 7, okay? Okay, so here for 1 to 9 f, that is, data is given, here there is minus 1. Now, 7 to 9 f is 5, because it's opposite, it's minus 5. So it's minus 6. Now, for part C here, and there's no 7 to 9, but by using the order property, it can be written negation of here now 7 to 9 and G minus F. Right? Okay, here we already know from 7 to 9, G is minus 4, and F is now 5, so that this whole thing is minus 9. Along with this 9, it must be, okay, 9. Minus 9 with minus 1, so that 9, okay? Area under the graph of non-negative function. Y equal fx is non-negative and integrable over a closed interval a to b, then the area under the curve y equal fx over the interval is integral of f from a to b, and we can write in this way. And so that this quantity will be the area under the curve. And let's try to evaluate the integral by interpreting it in terms of area. Okay, so we'll try to visualize the area. Okay, for this one, right now pictorially, here is from 0 to b in x-axis, and y equal x, that is y equal x, so that here now the integral is representing the area, and this length is b, and y equal x, so the height will be b, so that area will be half times bottom length and height, that is b squared. Okay. Now that is here pictorially from a to b, Now height is now c, so that that integral is representing the area. Quite easily the area is here, bottom length is b minus a, and height is c. Right? Okay, minus 1 to 1 integral of 2x absolute value. Okay, now visualize here. Minus 1 to 3, that is minus 1, and that is a 3. Now y equal 2x and absolute value, so that we have that way. So here we have this area and that one, two pieces. Now area is this area plus that one. Here length is 1. Now because y equal absolute value of 2x, then height is twice of bottom length. But anyway, the area will be half times 1 times 2. Height is 2. And right side, now half times bottom length 3. And now height must be twice of bottom length, which is 6. So that is left hand side is 1. Right side is now 9. So the total area is 10. Okay. For this one, we may try to use the property. So given term is same as integral minus 3 to 3 5 dx plus integral minus 3 to 3 square root of 9 minus x squared dx. For that one, the first portion, the interval length is 6 and constant is 5, so that 6 times 5 is 30. For next one, now let's try to visualize it here, and minus 3 to 3, and y equal here height is square root of 9 minus x squared. If you are putting this as y, then it's same as y squared equal 3 minus x squared. That means that x squared plus y squared is now, oops, that is 9, okay, 3 squared. So it is 9. Of course, here y is larger than equal to 0. So pictorially is representing the area, the upper half of the circle of radius 3. So the minus 3 to 3. So the area is this one. This total area is pi r squared, 9 pi. So that this portion is 9 pi over 2. So here, the answer is 30 plus 9 pi over 2. Okay? Now, compute integral from 0 to b x squared dx by finding the limit of Riemann sums. Okay, here we are using n equal subintervals with right sum. Then now from 0 to b pictorially, right now, y equal x squared, and that is given in this way, and 0 to b. Okay, we are making now n subintervals. Then for first subinterval, we have now here, okay, the interval length will be that b over n. So that will be b over n, and kth, so that right, the ck will be here k times b over n, right? And function value is x squared, so that here k times b over n squared, and that is bottom length. The summation is Riemann sum. Okay, so that equal here is, if we rewrite that one, then sigma k is from 1 to n. Now k squared and b squared over n squared and b over n. This portion is constant, independent of k, so we can put it outside, which is b cubed over n cubed, and then sigma k squared from k is 1 to n. Already we know the formula for that one, so that is the same as now b cubed over n cubed, and this is n plus 1 and 2n plus 1 divided by 6. And this portion, if we are considering this portion, and the bottom is 6n cubed and top is n plus 1, 2n plus 1. Now that portion is the same as basically 6n cubed, and if we just the expand, then that is 2n cubed plus lowered terms. As n goes to infinity, this term will approach 2 over 6, which is 1/3. So that in the limit, here we can get now b cubed is here, and then 1/3. So that's the final answer. Okay. Okay, now we'll go to final subject in the section average value of continuous function. Okay, earlier in section 5.1, we informally introduced the average value of a non-negative continuous function. Now we define more formally here the average value. Once f is integrable on the interval ab, then its average value on the interval is given in this way. The definite integral of f divided by here the interval length, that is average value. This average value is sometimes called mean. Okay, here, let's try to solve this example. Find the average value of f of x, and given in this way on -2 to 2. Okay. So let's visualize the problem. Now, that is -2 to 2. Here, the function fx is minus, okay, once you write down this way, equal y, and then that is same as your y squared is same as 4 minus x squared, so that is x squared plus y squared equal 4. Of course, here y must be non-positive. So that is a circle of radius 2. So that one will give here now. That is from -2 to 2. And integral -2 to 2 of fx will be the area. So the integral -2 to 2 for given fx must be area, which is the same as now. Okay, that is whole area is pi r squared, so the 4 pi, and half will be 2 pi. However, the function value is negative, so that it's -2 pi. Okay. So that here average value of f is the same as and 1 over p minus a, so the 2 minus -2 and times here -2 pi. And that is 4, so that is a minus pi over 2, right? That's the final answer. Okay, that is the end of section 5.3. Thank you.